As a reminder, for more Microsoft webcasts, you can visit Microsoft.com/webcasts. And again, I'd like to welcome everyone to today's MSDN webcast, Top 10 Dynamic Management Views in SQL Server 2005. And now, without any further delay, I'm going to turn the floor over to today's presenter, Greg Lowe.
Thanks. Hi, folks. I was going to say good morning, but it's early morning here. I gather for most of you it's probably still mid to late afternoon or something like that. So this session, we're wandering through dynamic management views in SQL Server 2005. What I've found when I look at the new features that have been added in SQL Server 2005, dynamic management views tend to rate a mention where people say, oh yeah, that's one of those new things that's been added. But what I've found that everybody seems to have put it on their list of things to have a look into at some time in the future, but they tend not to have actually got around yet to actually having a look at them. And so I figured it was worthwhile having a session where we just sort of take a little bit of time going through and having a look at what you can achieve using the dynamic management views. Now the session that I'm doing is meant to be targeted at 200 level, so hopefully we'll try and keep it at about that level. And it's a precursor to a session I'll be doing at TechEd in Orlando on the same topic, but we'll be doing a slightly higher level session there for those that attend. Now, prerequisite-wise, all I'm really hoping is that you are an existing Microsoft SQL Server database administrator or a developer. Probably either would find the session worthwhile. Now, who I am, so just briefly, I'm a principal consultant with a company called Redify in Australia. Redify is involved in technical readiness and consulting work. So I spend probably about 3 weeks of my month doing consulting work, and typically around a week a month of organising and or teaching workshops or training. I do try and keep a fairly high proportion of that straight-out consulting work rather than just lots of training work, but I do enjoy the training, and so do still tend to do quite a bit of it. Another one that I'm involved with is the SQL Down Under podcast. Many of you may or may not have come across this as well. As yet, I've been really pleased with how it's going. In fact, I keep looking at things that are popular in the developer community and that are often missing from the SQL Server community, and look at bringing those across. And I've looked at the success of things like .NET Rocks and some of the other podcasts, and the Polymorphic podcast and a few in the developer area, and trying to bring a sort of a high-quality podcast across into the SQL area. We've been doing it for probably about 2 years now, and it's been very pleasing, the number of people that are now downloading. I think stats-wise, we're up to sort of probably 15,000 a month or something now, and so it's sort of really pleasing to see that level of interest for SQL Server. But that's at SQLDownUnder.com. I'll give you a link again later in the show. But there are a whole series of interviews there with people that I think are notable in the SQL Server community, and good, I think, education material on a whole range of topics. I'm a member of the Microsoft Regional Director Program. I should pull out the word MSDN there because they don't use that word anymore. And very pleased to be a member of a great bunch of people in that group. And Microsoft MVP for SQL Server organised CodeCamp Oz and SQL Down Under Code Camp in Australia with events that are basically weekend events. And so if anybody is looking at having a wonderful holiday in Australia, I'd try and encourage you to try and pick a weekend where you could also come along to CodeCamp Oz or SQL Down Under Code Camp. And lastly, I'm also currently an author with Rational Press, and I have a book on building technical communities, which is kind of a little off track for most technical things, about to come out this month, and a book on SQL CLR integration as well, also due within the next few weeks. Now, agenda-wise, what we'll be looking at, I'll take a fair bit of time here to sort of show you through demos as we go, because the content of the DMVs tends to lend itself fairly well to demos, more so than talking to you about what they do. But we'll spend a few minutes talking about what dynamic management views are. I then want to show you how they can give you new insights into existing technologies and or existing problems that we are already dealing with. I then will show you how it can give you insight into newer technologies, so things that weren't problems before because we didn't have them, but have been introduced with SQL Server 2005, so new technologies and how we can use DMVs to look at those. And then I want to spend a little time talking about how you can make good use of DMVs. And a really neat or nice new addition to this is the ability to add custom reports and into SQL Server Management Studio, and that was added in Service Pack 2 of SQL Server 2005. And so I want to show you quickly how you can build and add reports involving DMVs and pop them into SQL Server Management Studio, where they'll be a lot more useful to you. Now, introduction-wise, these were added in SQL Server 2005, and there really was some equivalent of that in SQL Server 2000. In SQL Server 2000, we had a few views that gave you indication of what the internal state or health of the server was. In particular, we had sys processes, and we also had things like sys cache objects, were sort of system views that really, the important thing is that they weren't persisted information. They weren't sort of things that were like written in system tables. They were things that it was effectively giving you a view over what was actually just memory inside the server, or statistics being kept or held inside the server. So prior to the introduction of DMVs, what people would often do is they'd end up using system tables or probably running combinations of DBCC commands. And DBCC got a reputation for having an enormous number of sort of particularly undocumented commands that allowed you to get in and have a look at various things with the state of the system. We might also have used Profiler, and a number of things that we can now find out using DMVs would have required us to have already had a trace open inside Profiler. But now, when we have a problem, we don't have to think, that's a real pity I didn't already have Profiler open. What we can now do is use a DMV and have a look at what's going on at the time the problem occurs without needing to have to sort of take that action beforehand. There are also a number of things where we'd use Performance Monitor, for example, where we can now obtain things like performance counters directly from inside SQL Server using the DMVs. Now, we do this because we might want to be looking at diagnosing problems. The other reason we might do this is we might be looking to do some sort of performance tuning. And DMVs allow us to find things like the top 10 type questions. So, queries that have taken the longest to run, transactions that have been blocking for the longest period. Those sort of questions we can answer using DMVs. Now, there are both dynamic management views and there are dynamic management functions as well. In books online, they talk about dynamic management objects that cover both. Essentially, the only difference is that the dynamic management functions are basically parameterized dynamic management views. And so you'll find that a number of the views tend to return all the information, and where some of the dynamic management functions, we might pass to it, for example, which database do you want to have a look at when you're looking at the data? And so it'll only return the data for a specific database. Now, to get to the information in this, obviously we wouldn't want everybody to be able to sort of look at anything going on inside the server in this way. Now, you need select permission on the view itself, or on the or on the function. With any of these, though, we also need the view server state permission, and that allows us to have a look at any of the ones that have a server level scope. For anything with a database scope, we need to have view database state. Now, if you want to avoid somebody being able to do this across any of the databases, one way of getting around this is to create a user in the master database and then deny them permission to do this across the, if we do the deny, then they'll actually be restricted across all databases. So you can tie this down a lot further if you want to. Now, the DMVs and DMFs live in the sys schema. All of them have a sort of a DM underscore something naming. And the way they've structured the naming, we have DM underscore, and then the next part of the name is a category that the different DMVs or DMFs fall into. Now, when they were putting these in place prior to SQL Server being launched, one of the interesting stories I heard was that a number of the areas of the team were using these for effectively sort of a debugging from an external point of view, applications and things. And the idea was that they almost did sort of like a black box, white box type debugging. So if they were, the aim was to try and debug using just the DMVs and DMFs wherever possible, and to try and get to the bottom of whatever problem it was that they were trying to deal with something happening in SQL Server. And the idea was that if they could not get to the bottom of it, then they needed to go back and sort of fix the views or functions so that you could have got to the bottom of it using just those. Now, the first section here, what I want to spend some time having a look at is things that were already problems or things that we were trying to work with in SQL Server 2000 that having dynamic management views now gives us a new insight into looking at those sort of areas. Now, the categories that I think are most affected by this, these are not necessarily the ones that I think are the most useful of the DMVs or not, but just the categories that were things that already existed in SQL Server 2000 that we now have categories for in 2005. So I/O, we're able to have a look and see right down to the level of sort of bytes read and written and so on. We have database-related ones that deal with files and deal with physical layout. We have a rich variety that are related to query execution, and probably my most favorite DMVs and DMFs all sort of relate to query execution. We have full text indexing. There's support there for looking at what's going on with those. And probably my second most favorite ones are the ones that to do with indexes. Replication, number in place. The operating system itself, there are quite a number of low-level details we can get to, but in particular, we have the ability to get to performance counters from within SQL Server. I mean, they are stored in SQL Server and calculated. Stored is probably too strong a word, but they are generated and available within SQL Server and provided out to the operating system via the counters that are installed when you put SQL Server in place. All they've done now effectively is given us a view that allows us to have a look at those counters without having to go out directly out to the performance monitor tools out at the operating system level. So first up, I want to give you a bit of a look at some of these things that we can now do. Now, prior to having the DMVs available, I'll go slowly a bit for a moment, just in case your screens are still refreshing. But prior to having these available, people tended to do some pretty amazing things working with system tables. And even though Microsoft always said, hey, look, don't work directly with the system tables, and doing so wasn't sort of supported, the people tended to get right in and try and do so at an amazing level. Now, I'll just show you actually one example that I came across just the other day that had me completely fascinated, actually, and just how scary some of the code is that people write. This is one that was a question that appeared on a news group, and I love the fact that this guy was saying, look, I'm not very good at writing, procedures that involve at variable or writing things with variables. And yet if you have a look at the code that he was writing, he was sitting there sort of building cursors that dive through master sys processes and worked out which things weren't the agent and so on, and then sort of diving off, killing the SPIDs and so on. It just had me completely intrigued that someone who didn't even have a good grasp of writing and dealing with variables would get in there and start sort of trying to write code like that. So it's kind of intriguing how deep people will go when they start immediately finding the need to dive into things like sys processes. But anyway, what I want to take a look at first up is just where these live. And so if I pop into Object Explorer, and you notice if let's wander into one of the databases, so let's say master first up, and under views, we've now got system views, and under sys, the schema, notice that we now have a whole series of these things, so sys.dm underscore, and then we've got a category. So if you look at the naming of these, so DM broker is service broker related, DM CLR, CLR integration related, DB for database, execution, we've got full text search as FTS, IO, the operating system ones, and another interesting set down the bottom of the transactions. We have replication, and there's also one there for query notifications that can allow you to look at the state of the subscriptions. So that's the current set of these. In addition, you'll find under programmability, let's have a look. Trying to see if we've got under system functions, we've got a number here also that are living, that are functions. So sysdmdb, index operational stats, physical stats, missing index columns, and so on. There are a number of these things that are table-valued functions, and so effectively they're just parameterized views and really fall into the same category of where we had the DMVs, that all they're really doing is sort of limiting the amount of data that comes back to that for a specific database or specific table or so on. Okay. Now, the dynamic management objects, first thing to say is that they're a very interactive and dynamic thing. So they're not data that's stored on the system already in some way as like persisted data. This is stuff that's happening in memory, and what it's retrieving for us is the state of the system from memory. So if I start with the AdventureWorks database and we have a look at what's already in sysdm tran database transactions, as a good example, this is very similar to the sort of information we could have got previously with some of the system tables or using system stored procedures. The nice thing about this is that it's returned it to us in a relational form. So that means that we can do sort of queries and things directly against it much more easily than having to pull the data out into a temporary table or something to be able to query it. So if I look, in this case, where database is 8, where AdventureWorks, we don't have any transactions. So if I just begin a transaction and let's update the product table and change all the blue colors to light blue. Just take a moment. If we then look, we'll notice that we now have an entry in here in sysdm database transactions showing us the state of that transaction. And quite a wide variety of information. So the transaction itself has an ID. We have which database it belongs in, and of course we've limited it to a specific database. We've got when the transaction began. We have the type of transaction, and as we wander across, you'll find other very interesting stuff in here. Things like what was the count of log records that are involved in this. And so it's not just a case of, there's a transaction and this is where it started. This is some very low-level information. So, how many records have we written to the transaction log because of this? Others here. Database transaction log bytes used. So how much data has been written to the transaction log? How much have we reserved? We've got log sequence numbers, so we can tell where that is within the log file, and save points, and so on. So there's a wide variety of information available to us that really is transient sort of information. And so if I roll back my transaction, then clearly my transaction entry in here then disappears. Now, if you're trying to get this information from a fairly busy system, one of the things I've found is that sometimes if you're trying to sort of learn to use these, it's really useful to be able to go off and grab a snapshot of a fairly busy system, so you can sit there and have a look through and learn the interrelationship between the different views and functions. Now, what I've written, I'll make all of these scripts available on my blog, which I'll reference at the end. But what I've found the need to do also for just being able to do a presentation where we have some realistic data rather than things like the transaction I just started before, you need to be able to sort of grab something off a busy system to be able to get a good feel for what's going on. Now, I've built a script here where effectively we go off and create a database called DMV temp, and then what I've done is just literally done a select of everything from each of the DMVs into a table that's on that database that I've created. And all I've done, just to keep the naming very, very similar, so the scripts look the same, I've just called the table sys_DMCLR app domains, where it was sys.DMCLR app domains in the dynamic management view. So this means that I could then query an object like this from in the database and, of course, get a whole range of things back from a running system so I can have a good look at what's going on. Now, that works pretty well for most of the DMVs. Some of them, as I said, though, are DMFs, they're dynamic management functions. We need to do something a little more complicated than that. Now, what I've chosen to do in this is I've decided to grab all of the data. So if there is a function that just returns, let's take an example here. There is a DMV here, or a DMF, called sysdm exec plan attributes. That actually returns all the sort of set SET type attributes related to a plan. Now, the idea there is that normally it returns a table of those, and it returns a table of those for a specific plan. But if I want to capture at a moment in time the entire state of these, what I actually want is I want all of the plan attributes for all of the plans. So the way I've done that is I've said, look, I'll select the plan handle, which is the way that we identify a specific plan, and then I've said, look, give me back all of the attribute columns as well, and I've pushed those into what I've called function and then sysdm plan attributes. And the idea here is that then gives me a table that has all of them in it with the plan handle at the front, and then I can manually build myself a sysdm exec plan attributes, and that allows me to sort of build a partition or a sort of a parameterized view myself, which can then give me back the same information that the normal one would have. Now, notice that this makes good use of the new cross-apply operator that was added in SQL Server 2005. So the idea is that I'm making, for each entry in sysdm exec cached plans, what I'm doing is calling this function and passing the plan handle that I get from there. So the idea is that you've got it's a bit like a join, but effectively you've got a table on one side, and then what we've got is a table-valued function on the right-hand side. And for each row in the table, we're calling the table-valued function. And so I've needed to do that to get a variety of those. But then I've built this, and so we can go off and do that for all of the different DMVs, and we can get a sort of a snapshot of what's going on. At the end, I've caused it to then do a backup, but that was just simply so I could have a way of getting the data back. So while I'm going through this material, what I'm showing you, we'll do a number of things live, but in addition, I've got a couple of these databases where I've sort of captured this information beforehand just so that we have a few production scenarios to work with. And two levels I kept this at. This DMV-WJ is actually from quite a busy online flight booking system that typically has around 14,000 concurrent users on the website and quite substantial state storage on a web application. The other one I have here, DMV-FA, that's actually taken from a government authority. And again, what I've got here then is a series of tables, and we can sort of query those and have a look at what the data looked like at the time I took this snapshot. Now, given the fact that all of the things don't get collected at the same instant, it's not a perfect scenario, but at least it allows us to have a good look at a fairly busy system if we want. All right. So anyway, that's where those scripts came from. Now, if I start going through the ones that I think are the most interesting of the DMVs, we'll start at the sort of bottom, but TempDB has become a lot more important in SQL Server 2005. So TempDB, the performance of that and is now often, hopefully, you're really looking for better performance than you were in earlier versions. And there's a whole lot of things that are using TempDB that weren't using it before. In particular, we have things like the row version store. So if we have database snapshot isolation level, or if we have even things like triggers now, all of these tend to use the row version store where they didn't before. So TempDB has become a lot more important. There are a whole series of dynamic management views called DMDB, and they're things like file space related. And all of this series, at the moment in SQL Server 2005, these only work against TempDB. I can only imagine that in an upcoming or later versions, they'll expand these so that they work against other databases. I'm only guessing there, but I think it would seem like a reasonable thing. And so if we look at DMDB file space usage, this is kind of interesting in that what it allows us to see for database 2, which is always TempDB, then if you look here, we've got literally for each file, we've got a list here that'll show us, how many of the pages are available, how many of the pages are used, how many are allocated, and we can even see things like mixed extent page. So a mixed extent is where we have an extent which is sort of 8 pages been allocated, but a mixed extent is one where it isn't what they call a uniform extent, where all of the pages in the extent are from the same object. That means that there are sort of pages from different objects inside that. So we have a degree of that going on inside that as well. If we look at that one from a sort of a busier system, as this is from our local one, just wanted to show you that this is how I would then query the one off my busier system. So I'd say off the WJ system, DBO, here's my table where I captured that same sort of information. So just want you to see that I can see exactly the same sort of information off a somewhat busier system. Another example here, virtual I/O file stats. Now, these are very interesting because they allow you to see the number of reads and writes and number of bytes read as well. So not just the number of reads and writes, but the amount of bytes involved. Now, I find this kind of interesting because it allows you to see how big the files are in a query, but also find out things like, what are your used or how busily used are they? And effectively, you can also then go and, of course, and rank these in terms of how often they tend to get used. Now, as an example of this one, there are also DB session space usage. Now, this one, again, notice that the database is always 2 in this case. I'll scroll right down and you see all the way down the database is 2. This is, again, an example of one that in the present version only works against TempDB. But so this is then on a per session basis, and you'll find a lot of the DMVs use the session ID, which is kind of like a session going on against the database. They use the session ID to sort of be the key or to join when we're looking at the DMVs. Now, in this case, it's showing us by session who's making what use of TempDB. Of course, and that, again, might be interesting if we have performance issues within TempDB in terms of allowing us to go and sort of track down which session it is that's making what level of use of TempDB. A couple more of interest here, so as we're going, I think, into increasingly more useful, we have a whole series that are related to transactions. And a good example of this that relates to new row versioning is SysDM Tran Active Snapshot Database transactions. These ones are obviously not for the typing challenged, but some of these are very descriptive names and good stuff. So this one here allows us to have a look at transactions that are sitting there related to row versioning, and importantly, the sort of thing that we can find out here is elapsed time in seconds. So if we have something that's been sitting there for a period of time, we can start to work out which things have been taking the longest running against the transactions. In addition, for transactions, we have a list of the overall active transactions we can pull back. Similar sort of level, interesting things like isolation levels, I might add, are available in here. Now, I find that kind of useful because one of the problems I often run into in production scenarios, it's very, very common to end up with things like serializable transactions that don't need to be serializable. It's very, very common with COM+ applications in particular, where the default for COM+ was serializable, but that often ends up producing all sorts of blocking in many systems I work against. And in many cases, if you go back and have a look, they don't need to be at that level. This sort of view allows me to go in and sort of find sessions and transactions related to that. SysDM current transaction, straightforward, no surprises there. Database transactions allows us to have a look on a per database basis. So notice many of these are a view of a very, very similar things, but giving us, either a per database or a locks or a session basis. So we have lots of different ways of looking at the same thing, some of which are more useful for queries we're trying to write than others. This one allows us to have a look at the locks that are currently being held, very, very similar to sort of an SP lock type thing. So rather than what we would have done in the past with SQL Server 2000, if we were trying to write something that dealt with the locks on the system, we typically have to create a temporary table. We would have had to do an insert exec to run SP lock to basically pull back the details of the locks. Then we'd have to write something that queried against the table. The lovely thing with these now is this is giving it to us in a very relational form where we can go off and do appropriate queries. We also have session transactions, so we can look at based upon a specific session. And we can tell here, for example, whether it's local or not, and the enlistment details. Now, another one, if I'm going up through what I think are useful DMVs, another one allows me to have a look at all the cursor usage going on in the system. One of the things I'm endlessly trying to do is sort of track down and replace older cursor-based code. If I have a look at things that, when I'm doing performance tuning work, trying to find things that tend to be the biggest problems, often code with lots of cursors and lots of temporary tables is exactly the sort of thing that often is a good starting point to get replaced. Now, we could have a look at all the procs and say, look, and see a big sea of procs and go, gee, the question is, which ones are the ones that are really getting used all the time? Now, the nice thing with this is that I can dive in. I've got none open at the moment, but what this allows me to do is have a look at who's actually making use of cursors right now. And so, when things are either a bit blocking or taking a long time to run, I can get a constant feel for which parts of the code are actually being used that are using cursors. And that allows me to go in and sort of tune those particular procs or areas. I mentioned that we can get to the performance counters, and so in the SysDM OS performance counters, we can pull back the sort of things that we would get from the objects and counters that we'd normally look at inside Performance Monitor. And so a good example here, right on top, in this case. So buffer hit, cache hit ratio is saying basically how well are we doing with getting sort of hits against our buffer cache. Now, the really interesting ones start when we start hitting the areas to do with indexes and, as I said before, execution. Now, first up, there's a couple that are, quite a few actually, that are called SysDM index something, but there are also some that are listed as DB ones, but are very much, I think, index related. Now, the main one I look at here is SysDM DB partition stats. Now, this one, notice it returns back. So we have an object, and so where we're looking at tables, I'm interested in objects, and we've got the index ID here. Now, for a table, if we have an index ID of 0, then that means it's a heap and we don't have a clustered index. If we have an index ID of 1, then we're talking about the clustered index for the table, and index numbers above that are sort of non-clustered ones. Now, this will return details for each partition in the table, and keep in mind we might also have the table partitioned. But notice that the sort of information that's returned here, we've got in-row data page count and used page count. As we wander further across, we've got lob figures, so these are the large object figures. We've got row overflow. Now, this was introduced in SQL Server 2005, but we have this idea of overflow pages where once we start having pages that are bigger than 8K with variable length data, we're able to go across and do overflow pages. But it's often very hard to get a feeling for how is that being used or not being used within the system, and how much impact does that have. And so we can query that directly from in here for each partition of the table. And so another example here, if I just said, look, give me the object ID, which we could link to sysobjects and find out the object name and so on. But if I just said object ID here and then said sum of the in-row data page count and the use page count from partition stats where we've got index 0 or 1, then that allows us to have a look at the space allocated to the different objects table-wise, where we've then got, and you'll find at least one entry here for each table, and that allows us to have a look at how many pages are used and how many have been allocated. And so this is a quick way, effectively, to sort of pick up details of the space being used by specific tables in the system. Now, the ones that have had probably the most discussion of any out of the DMVs, we've got this one here and the missing index one. So first up, SysDM DB index usage stats. This one allows us to have a look at how the indexes on tables are being used. One of the common problems I come across is that people add indexes to sort of support something that they're building at the time, but even if that thing that they were building gets removed, the problem in most systems is that the indexes stay around and nobody has any idea why the indexes were built and if they can now be removed. And so you often find DBAs sort of seeing this big list of indexes and they're sort of really thinking, gee, it'd be nice to sort of tidy things up and tune things up a little bit by sort of removing some of the excess if needed in terms of indexes. But they have absolutely no idea at all whether a specific index is being used or not. And so SysDM DB index usage stats allows us to have a look per database, per object. We can see the individual indexes, but then notice that we can see the number of times a user has seeked, so made sort of like a point query down through the index, or we have scans where they've actually picked it up in a range, lookups, how many times they've updated it, and we can also see the last date and time that this occurred. So we have an idea if it is actually happening. Now, it's important to note that many of these DMVs only keep the data since the system was last rebooted. Since the last time that SQL Server was started, which of course might be slightly different. And so in many cases, if you're trying to make longer term use of these, I often find that what I need to do is create a table and then put, say, for example, a SQL Server agent job that's fired up that captures this information, perhaps, I don't know, every half hour, every hour during the day, and then at least that way you get sort of a historical look at how that is, even if the system gets restarted, and sort of persist that off to a table yourself. But at least that way you can, with quite good confidence, know whether or not an index is actually being used. And that can allow you to sort of remove those. Now, this one here, I'll grab this from a sort of a busy system, but again, if we look at SystemDB physical stats, what that's returning is back the type of thing. So we're looking at heaps or clustered indexes and so on. And this one I find interesting because it returns us the average fragmentation. And so this is a way of looking at the level of fragmentation that's occurring at the moment inside each of the different types of indexes we're working with. We can see the average fragmentation size in pages, and again, a bunch of other basic information about the index itself. Okay. Now, so that's physical stats and how it's laid out. If we look at operational stats, then what this is showing us is counts that relate to things like, how many leaf level inserts were made, or deletes, or updates, and so on. And so this is giving us a very, very detailed look into what's going on in terms of internally in our indexes. How many range scans have we done? Also in here, row overflow fetches and so on. As I mentioned, we had row overflow areas allocated in 2005. This allows us to go in and have a detailed look at basically how much is that actually being used against this index. Because one of the things that is always a sort of a bit of a concern is that once you start getting into an overflow situation is, how much access is being needed to be made into the overflow pages. But the one that's probably caused the most discussion is SystemDB missing index details. This is very, very interesting. What it allows us to do is have a look at what indexes it would have been nice to have had on the system. Now, previously we could do that by getting a query and tuning it with SQL Server with Tuning Analyzer or now the Database Tuning Advisor, but this allows us to have a detailed look at what's going on while the system is running. Keep in mind that this only lasts for as long as till the system reboots or restarts the service. It also has a limitation where it keeps only up to 500 entries in the list. Now, a lot of people are finding that a bit of an issue because you'll find that it often suggests a large number of included columns. Now, in SQL Server 2005, we had the ability to just include columns at the leaf level to create covering indexes. And the problem is that if you tended to do a lot of select asterisk from whatever in your select statements, you will find that it would have come in here and suggested a whole lot of included columns, often including every column in the table. And clearly that wasn't sort of a very useful entry. Now, what they've done in Service Pack 2 is they've changed this so that once they get up to 500 entries in place, they then start lopping off the top 20% of these each time, and they sort of do it on the basis of usefulness and age, were the two things that they look at here. So what you'll find over a period of time is you do tend to get sort of more and more quite useful details in there. Now, the ones that I think are the most useful of the DMVs, apart from those missing index ones, are the execution-related ones. Now, these allow you to write, people have jokingly said SP Who 3, or every sort of combination of things that we would have done with SP Who or Who 2 before. First up, we've got, actually, I'll start with sessions. If we look at sessions, this gives you one entry per session when they're logged on, and details, I'll go down to something a little more useful. And what this allows you to see is, again, the program that they're running, the process, their login names, and so on and so on. So a wide variety of information about the session itself. Now, attached to each session, you might have a series of requests. And this then allows us to see command-wise what's going on with the request. So notice that, of course, I'm doing a select, and that was the one that is actually running. And if we wander our way across here, there's then a SQL handle. Now, all that is that whenever they need to store a SQL piece of text, what they do is they store that in exec SQL text, and you have an index into that using the SQL handle. All it is a hash code on the SQL text itself. We also then have another interesting one here, of course, is the plan handle, and so where we have the execution plan that's associated with the request, again they hash the plan to create a plan handle, and we can even pull back from things like sysdm exec cached plans. We can go in and get the query plan that's associated with the request. Okay. In addition, there are a whole series of statistics we can pull back in relation to the queries. So again, the SQL handle is often the thing that we need to join with. We've got a statement start and offset. Whenever you look at either, in this case, the SQL text itself, it may be that what we've got is a series of plans rather than just one plan. And what this is here is showing you is that out of the SQL text associated with the request, it's where is the statement that the plan relates to. So you can literally build yourself, say, a little function that would take the SQL text and take the offsets and return you back the actual piece of SQL that's being run. Okay. And, of course, I'm mentioning that in SQL Server 2000, there were some equivalents of these, and things like master sys processes and syscache objects were very, very interesting things that would allow us to have a look at what was in cache. And so these things kind of replace the use of those. Now, one last thing I want to mention is that in DM exec requests, another interesting column in here that allows for some interesting applications is there's a percentage complete column. And I've found that this isn't updated by all the commands, but there are a number of commands that do seem to update the percent complete. And for example, checkdb, if you're running dbcc checkdb against large databases, it can often be hard to know how long the thing's going to run for. And it does update this percent complete. So if you kept querying this, and you could query the percent complete, and you could do that basically looking for commands that were dbcc something, then you could actually get an idea where the dbcc checkdb is up to. Other commands that I find useful for looking at this are things like backups. You could build something that sort of polls and has a look at where a backup is up to as a percentage. Okay. Now, we've had a look at a fair variety of things there so far. These last ones are shorter, so don't get to worry we're going to be here forever. But the next thing is just the newer technologies. We have things like common language runtime integration and mirroring and query notifications and service broker and so on. These have all been added, of course, in this version. And we also have new objects that allow us to go and have a look at those as well. So if I go back to a sharing slide, and just to give you a quick look at some of these, as an example, in my AdventureWorks database, if I have a look at sysdm CLR app domains, I don't have any CLR-based code running at the moment. If I run the stored procedure, which is a managed stored procedure, if I then have a look at sysdm CLR app domains, I can then see that an application domain, which is kind of a housing project for assembly code, basically we've got one of those loaded now. You'll find most of these are joined together by app domain address. So you can see the address that the particular app domain is sitting in memory. Now, the one that's of interest in here, I find most of the time, is this state here. And so in this case, this is a state that's just saying, look, it's a state that's shared, and it's also giving us an idea which database and which users involved in this. If I look at sysdm CLR loaded assemblies. This is just a list of the assemblies and when they were loaded. CLR tasks is showing us the tasks that were associated with that. And the thing I mentioned before, that state, why that's important is that a lot of people are sort of concerned that CLR code might get, carried away and monopolize the CPU and things like that. That isn't really so much of a concern, but you are able with the DMVs to have a look in there, and you can see in the state if a particular piece of code has been sort of punished by the system. Sorry. And that allows you to have a look at code that is probably too CPU intensive and should probably be doing an occasional yield. If we look at SQL CLR properties, this allows us just to query where is the version of SQL CLR that's installed, and in my case it says CLR is initialized, but there are other states that would indicate, this is something that's not currently able to be used. So you could, rather than trying to execute code and have it fail, you could actually go in and query whether or not CLR integration is enabled. I mentioned earlier row overflow. So with things like SysDM DB index operational stats, I can pull back information on sort of how many row overflow pages are used in indexes. Also with index physical stats, there is a detailed option on this. Now, what's interesting with this is saying, look, for this database, give me all the indexes and give me detailed information. Where this is kind of interesting is that we now have XML indexes available. And if I'm doing this against AdventureWorks, there are some from memory. So there we go. For example, we've got a primary XML index in place. Now, what this allows me to see are things like the average fragmentation percentage, so on. So we can find out how fragmented they are. The server that I pulled, one of the busy servers that I pulled the information off earlier, was using database mirroring extensively. If I look at database mirroring connections, this shows me the connections, but importantly, some of the other detail across here, let's have a look. Apart from things like, is it using encrypted connections and so on, I mean, that isn't the sort of thing that would change much. But the ones I find kind of interesting here are, is receive flow controlled or is send flow controlled? That allows us to get an idea whether the network is causing problems latency-wise with the mirroring, because we can find out if flow control has had to be applied. Service Broker has a couple of these associated with it already, and this one has no connections associated with Service Broker, but we have a couple of queue monitors inactive and sitting there. But again, we can query that. And TempDB is now used for a row version store, and there are some queries there that are related directly to the version store itself. So things like top version generators, and we can also look at the transaction version store. And so we can have a look at what causes the things, and we can also have a look at what transactions are associated with versions of rows in the data store itself. This information gives us a wonderful look at what's going on inside the system. Now, last thing I want to sort of show you is how we might use DMVs in a sort of practical sense, and just a really quick look at custom reports that were added in Service Pack 2. Now, these are the same as the sort of reports that we'd use in reporting services. We can build, and in fact, I'll just dive straight into building one because we're running a bit short on time. And let's go into, I think it was there already actually, Visual Studio 2005. Now, all I'm going to do is create a very, very simple report. So if I say new project, and we're going to pick a report server project, I'm just going to call it DMV reports. Create the project. Then inside here, I'll just say add new item. I'll create a report. Let's call it session connections or something. That sounds like something we might be able to work with. Now on our report, I'll need to add a new data set. I'll put a connection string here to the local SQL Server and AdventureWorks, but the important thing to note is that this isn't actually used. You use it in your testing, but when you go to build or sort of execute the code, it uses its own. Now, if I have a look at, if I say select Asta from sysdm exec connections, and I'll just quickly execute that, notice that this pulls us back details about what's going on connection-wise. And so maybe the thing that I'm interested in is the connect time. So let's say session ID and connect time we might be interested in. And let's have a look, what else do we want? No, in fact, look, that'll probably do for the moment. And the other thing we might want is that we might want to get some information about the login name. Now we can get that let's have a look here. Let's just to quickly show you as well. In fact, getting tight on time, I might just do something with the connection. So dmexec connections. I was just thinking we could have actually done a bit of a join to get a little more info, but this will do us for the moment. And if let's pull a table onto the report, and then from our data set, I'll just grab the session ID and the connection time, and then maybe things like, the number of reads. I mean, it really doesn't matter what we pick. And this is then a report I can preview. Won't be the prettiest looking report you've ever seen, but I just want to give you an idea of the mechanism by which we do this. And so if I, perhaps just to make this look a tiny bit tidier, I'll make that right, make that left justified, we'll make that right justified. Yeah, there we go. That's our pretty looking report. Now, if I just save that, the thing I want to show you is that inside SQL Server, we can now, in here, let's say just right click, and in fact we could do it at the server level. Notice under reports, we've now got an option for, there's a series of standard reports. They put all the standard reports on the system here because they found they weren't very discoverable. But there's now a series of custom reports, and notice that it's not populated in the list. Now, if I drill in and find that report that we just built, that's the RDL file, is the report definition file, we get a warning that says, look, you're about to run a custom report. What this is trying to avoid, of course, is Trojan reports, which sounds a bit dramatic, but because it can execute any SQL code that you could execute, it does have limitations where it won't allow you to do expressions and all sorts of things, but you could have a malicious report. Now, when you run the report, it runs in your current connection context in Management Studio, and so notice that this is now an information pane that I've dropped directly into Management Studio. And if I go to run this report again, you'll find that when I right-click at that level again under Reports, it's now added that into the list of reports that are in my recently run list, and I can just literally, I could turn that warning off, but that'll just now run as a standard report. This is a very, very neat thing that allows us to build queries using our DMVs and sort of drop them inside there. Now, mindful of time, so I'll just mention that sometimes you want the report you're generating to be based upon the object that you right-click on in the object tree. Now, they do allow you to do that, and when you run a report, there are a series of parameters passed to the report that allow you to see the object name, the server name, and database name, and so on. And so you could build an EMV-based report that relates directly to some specific object that you've right-clicked on. Now, the other thing I want to talk about is just how you go about learning to use the DMVs. Now, a really, really good use of this are the samples that ship with the product itself. And in particular, one of the things they added in SQL Server 2005 was a concept of this performance dashboard. And so if I dive in here and right-click again, notice I've got performance dashboard main, and I run this. This is a very, very interesting bit of work. They provide all the RDL files to you. It's a download off the Microsoft site right now. It's the performance dashboard for SQL Server 2005, and you'll find that it's quite a complex report. It gives you a lot of good examples of how to use the code, because the code is there as well. And if you notice also with the report, they've even done drill downs, which it is possible to do drill throughs on the report, and that's showing me the current requests, and here's the SQL text and so on. This is a very, very good way to learn to use the DMVs in a sort of a practical sense. You'll be able to get to see them in action. So look, session summary-wise, this is it's a wonderful new addition to the SQL Server product line and gives us sort of detailed insights into what's going on inside the server. Certainly useful for looking at problems as they're occurring, and can also help you sort of with ongoing performance tuning. And then I think the really neat thing is that when you find something that's useful or queries that you often want to run, we can sort of integrate that in and run that via reporting as well. So look, thanks for that. Thanks for listening today. If more details, I've got my blog is at msmvps.com/Greg Lowe, and SQL Down Under is the SQLDownUnder.com site, where I've got the podcast and links to actually a new SQL Server search engine. There'll be links to that going up in the next few weeks. And also there's another short podcast going up there called SQL Snapshots. If you want to contact me, I'm just greg.lowe@redify.net. The samples from this session I'll put up on the blog site as well. And I'd say that's back to you, folks.
Excellent. Thanks, Greg. I do want to remind everybody that they can print a PDF of today's session. To do that, just go to the File menu in your upper navigation bar. Now, if you have any questions for us, now's the time to submit them into the Q&A panel found at the bottom of your live meeting screen. Also, I'm going to be posting a survey here in just a minute. If you would all please take a moment to fill it out before you log off. We really do appreciate your feedback. As a reminder for upcoming and previously recorded webcasts, you can visit Microsoft.com/webcast. You can go here to access this webcast, which will be available for download in about 24 hours. Now, if you have any webcast content ideas, if there's something out there that you would like to see and haven't yet, we would love to hear from you. Just take note of this link here. And for anybody who's interested in receiving a free 14-day trial of Microsoft Office Live Meetings, you'll want to visit Microsoft.com/presentlive. Now, for filling out that survey today, you're going to be automatically entered in to win this 30-gigabyte Zune digital media player. So it gives you a little incentive to fill it out for us today. And here is the survey. Please follow the links provided to complete today's webcast evaluation. And Greg, do we have any questions waiting in the queue for you?
Indeed, there's one in the queue. One of the people were asking what was the DMV FA. Now, what I was saying is that I had, rather than trying to emulate busy systems, I had captured some information from a busy system using that script that I showed earlier. And DMV FA was just one of the databases where I'd captured that, and that was from a sort of a government authority one. But when I've got the queries there, whatever the name of the DMV was, I created a table with that name effectively in that database called DMVFA. So that just allowed us to have a look at actual running ones rather than just the ones I could run up quickly on my notebook.
All right, looks like we do have a few more in there, Greg. If you want to actually open up that question manager in the bottom right-hand corner of your screen, it'll pop open that window for you.
Now, first question, is from Chris is saying, look, what performance impact might there be running this capture the system information? Look, in general, I've found it's very, very light. The only thing is that there are a couple of them, particularly related to the query plans, where it seems to take quite a while to retrieve the information. Now, I think part of the problem is that one or two of them really should have been DMFs instead of DMVs, and sort of limit the information to a single database. And so I sort of find some of that it's a fair bit of a time it takes to do this. A lot of people are sort of concerned. They're saying, well, look, how much effort is SQL Server taking to sort of calculate and keep all these figures? In general, all that's happening is it's giving you a view of figures that it already has inside the system. So it's not like it's having to sort of generate the information and keep it around to do this. Overall, the performance impact's been very good. There's a question on, are there any DMVs for monitoring log shipping? Look, I don't know. In fact, that'd be a great one. If you want to pop me an email, I'll find out. Certainly there are currently 70 or 80 of them, and I've been through and read all the books online and read everything I could find online, but I don't ever recall seeing the word log shipping come up at all. So, but that's a really good question, and if there are not, it'd be a really good thing to pop into the Connect site to sort of suggest that those things might be added, because I could well imagine that monitoring of that would be something that would be useful to have. But I'll certainly pop me an email at greg.lowe@redify.net, and I'm more than happy to follow that one up. Now, for someone who's working with both SQL Server 2000 and 2005, saying, look, rather than accessing the system tables in production systems, can I create an equivalent view in 2K? Basically, they didn't give us access to this in 2000. As I was mentioning, there are a couple of things like sys processes and sys cache objects and so on that allow you to see some degree of this information in 2000, but you really don't get access to it. Another thing I didn't sort of mention, in the two systems that I captured the data from, even though they were both running SQL Server 2005, one of them was at database compatibility level 8.0 still the SQL Server 2000 database compatibility level. That did restrict some of the data I could capture on. That was in my DMV WJ one. I didn't have quite the same amount of information from that one. So if you are running at an earlier compatibility level, that'll also limit what you can do. Okay, from NT, nice informative. Thanks a lot. That's great. Thanks, folks. More information on offsets. Yeah, actually, that's an interesting one. What I'll do there, I'll post up an example. I've got some links that I'll post up after the session, and it's from Ed. There are some good example bits of code around the web that I'll point you at some links. One of the guys in his code has gone through and built a function that allows you to have a look at, that basically takes the offsets, applies it to the SQL text or whatever, and returns the value back to you, because there's a little bit of fiddling around you need to do, not just sort of like a substring. Imperius, great information. Thanks for giving us Saturday morning. Yeah, very welcome. And I think that's the lot.
All right. Well, with that, I'd like to extend a very special thank you to you, Greg, for your presentation today and for answering all the questions we had come through the queue. I also want to thank the audience for attending today's MSDN webcast. And ladies and gentlemen, this will conclude today's session. The audience may now disconnect from the audio portion of today's presentation.